200. Little cubes. Now, what is the length of one of the 100? 10. Okay, 10 on this side. What is the breadth of one of these? 10 also. Okay. So what is the height of this tank? What is the height of the tank? 10 also. Okay. Not too bad. Now just now I asked you to take 30 cubes, right? I said 30, 30. 30 cubes. Okay, 30 cubes. Count 30 now. No more than 30. 30 30. Okay, 30 cubes. I want you to make a cube with the 30 cubes now. 30 centimeter cube. Okay, 30 cubic centimeters. I want you to use 30. Count 30 first. 30, 30. Okay, and make a cube out of it. Alright? I want you to use 30 small cubes to make a cube. Count 30 cubes first. Have you counted 30 cubes already? Okay, now I want you to make it into a cube. Just like what Adrian did just now. A smaller version of mine. Do you think it's possible? Yes. Try. Can I use 30 small cubes to make one bigger cube? Can or not? Cannot. Huh? No, cube. Can I make a cube? Can I make a cube using 30 cubes? Is it possible? I did see you trying. Is it possible? Why is it not possible? Jared says, can we make a cuboid instead? How come you suggest it's a cuboid? Yeah, so he says, okay. Answer says, because the length must be equal to the breadth must be equal to the height. So that it can be called a cube, right? Correct or not? Can the number 30 make a cube? No. So what numbers will be suitable? Alright, let's look at this page. Fill in the numbers here, page 35. On page 35 here, just now Adrian solved one of them for us. Okay? And Ryan said it very loudly. I can use 27 smaller cubes to make a cube. That's possible. Okay? And Adrian, what is the length of the cube that you had just now? Sorry? 3. So, he said you used 27. And it is 3 times 3 times 3. To be called a cube, the length of each side has to be the same. Length, length, length. These three lengths, length times breadth times height, all sides must be equal to give you the number of cubes that is possible. So is 30 possible? The answer is no. Why did Miss Lim ask us to do the impossible, right? Now then what other numbers are possible? Try now. 27, 40. Look here. Let's go with this. The first one is a small cube. 1 times 1 times 1. 1 cubic centimeter, cubic units. If I use 2x, can you make 2 for length, 2 for breadth, 2 for height? My cubes don't seem feel friendly. Took out from a different box. Yeah, some of them are not so. Yeah, I think I took the wrong cubes to use. I steal somebody else's cube. I want to eat some cubes. Yeah, take this one instead. Because my cube has edges they don't fit. Okay. Have you managed to make your 2 by 2 cube? This is like a smaller 2 by 2 Rubik's cube. Have you made before? Have you made this out? Okay. So for this one, what's the total number of cubes that you use? 8. And what will be the number that made up 8? 2 times 2 times 2. Very good. You realize that I have like two layers of cubes. The first layer is 4 cubes, 2 by 2, 2 times 2. And I add another layer, so it becomes 2 times 2 times 2. So I have a cube like this. Okay, what is the next number of cubes do you think? 4 times 4 times 4. How many cubes is that? 32? 64. 4 times 4, 16. 16 times 4. 64 cubes. You would like to try to make this 64 cube? Try that. No? Tired already. Okay. Now, if I go down, if it's 5 on one side, what do you think is the total number of cubes? 5 times 5 times 5, 125 cubes. Now, have you heard of these terms called square numbers? Do you know what square numbers are? I've said it before quite a few times. In your exam, it also came up before. What are square numbers? Yes, example. 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. These are all, the answers are all square numbers. So what do you think these numbers are called? 1 times 1 is 1 centimeter square. 2 times 2 is 4 centimeter square. 3 times 3 is 9 centimeter square. Those numbers are called square numbers. Now, you have 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. What do you think 8 is the unit of measurement? Cubic centimeter. Now, 3 times 3 times 3 is 3 times 3 times 3 again. 27. 27, the unit is cubic centimeters. Now, when I say 1 times 1 is square number, 2 times 2 is square number, 3 times 3 is square number, 4 times 4 is square number, cm square. Now, I have 1 times 1 times 1 is cm cube. 2 times 2 times 2 is 8 cm cube. 3 times 3 times 3 is 27 cm cube. What do you think are the numbers here called? What type of number? They are called cubic numbers. Can you see? Can you understand what I'm talking about? Square numbers, what do you have? 2 times 2, 3 times 3. What does cube number mean? Times it again. Can you see why the unit is different? Okay. This is for cubes. Just now Jared says, let's try cuboid. Wait. Before we move on, can you see this special symbol? We are going to try this special symbol very soon. It's called cube root. This is very important, Start it now. Cube root. Look carefully, look carefully, look carefully. Angel said a very important term. On page 37, there is this introduction of a term called cube root. Now, when I asked just now, Adrian, how many cubes did he use? He used 27 cubes. That was the volume of his tiny cube. And then when I asked him, what is the length of one side? He said it's 3 times 3 times 3. Here's the shortcut. If it's a cube, all I need to do is to press the calculator, this special symbol called cube root. Put the 27 inside and you press equal, it will give you 3. You know where is it on the calculator? Yes. You know where is it on the calculator? Yes. You try to press now. Shift, then the root, square root sign. So just now when I asked Adrian, you use 27 cubes. What is the length of each side? It's like working backwards, you know. Actually, he found 27 by using 3 times 3 times 3. Now, here's a shortcut. I promise it, premise 6. We're going to learn this new identity called cube root. Angel says, then what about square root? It looks like square root, you know. Can you find where square root is? It's here. Can you see where square root is? It's here. Can you start it as well? These are the two most important new things at primary 6 for the chapter of volume. Otherwise, most of volume we are learning in primary 5 already. Okay? So these two are the two most important new things at primary 6 volume chapter. The first one, the cube root. It is the symbol that looks like square root, but it has this tiny 3 on top. Okay? It's for helping us to find out if I'm given a volume like address 27 centimeter cube, I can find its length easily by pressing the calculator square root 27. Is that okay? Now, then Angel said, but isn't it more like square root? It looks like square root, it looks similar to square root. And that's why I say, let's take a look at square root. And what is the usefulness of square root? We'll find out very soon. Now we go to cuboid, okay? Just now I asked you to take 30 cubes, right? Now I would like you to flip to page 29 and answer the questions here. For cuboid, you can use the cubes to help you. Aiden, if you're not too fond of the cubes, it's okay, you don't have to use the cubes, but you must try to answer the questions here also. Hey, but you built something so cool in your table. I can see. It's very nicely done. Yeah, it's so nicely done. I'm impressed. You should feel more confident about yourself. It's possible, okay? Now let's try with the cuboid. You have A, B, and C. Let's find out 3 different cuboids. You can build cuboids now. 3 different cuboids that is made using 24 cubes. The first one is suggested here. Let's try this one here, the example, using one side is 4, one side is 3. What do you think is the height of the cube? 2, okay. There's an easy calculation, 4 times 3, 12, 12 times 2, 24. Fill in the rest. Where's your book? Fill in the answers, please. Does it work? You want to try it out? Huh? In exam, of course, no cubes now. By exam time, you should be able to find out the answer without the cube. Now you want to write the answer in without using the cubes. Ken, I'm not stopping you. But test it out. Are you sure it's the number that you write down works? Okay? So, Darren wrote 2 times 3 times 4. Do you think it works? Try that. Oh, that's very nice. I think it's very nice. Very nice. $29. Fill in the answers for page 29. The first one is given 4 times 3 times 2. Is there any other measurements? Hey, 2 times 3 times 4 is the same thing as 4 times 3 times 2, isn't it? You give the same answer. Yourself. It's the same answer what? You're making the same cuboid, isn't it? You make and try and just make and try and see. You will look at it yourself. Make it, then you will realize. You take so many cubes put in front of you and then before you see it. How are you going to make sense of what you're doing? You wrote there 4 times 3 times 2. Is there any different from 2 times 3 times 4? No. Is it going to be the same cube? It is going to be the same cube. Cuboid, can you please use the cubes in front of you? Give it a try. Hey, Adrian, cuboid already. Hey, 10 minutes I'm calling this over, you know. That's the time that you are using this real item to do your maths. Other than that, you will be doing more problems already. Why aren't you putting your hands in the cube? I'm really saying this. Boys and girls, you cannot stop at I want to use the cube to build fun things and houses and guns, then to stop. If you cannot use it to help your learning, and then learning stop as I look at this page, I don't know how to fill in, that's not helping. So, just now some of you wrote 2, 3, and 4. It gives the same value. Is it correct? I made the cube out of length. Yeah, it's gonna be the same thing, so you can't use 2, 3, and 4 again. Now, if you feel like, oh, I'm so tired, we only got 10 minutes left, okay? And for minimally, can you at least make one layer of the cuboid? Look, for example, I made here just one layer of the cuboid, like the one that's drawn here. 4, 3, and I'm missing 2. Now, if I have another layer, say I lazy to build, I just stack it on top. Now, so I stacked up and it looks like this, like the one here. You realize that, okay, I have this here, length 4 times 3 times 2, 4. If I were to take this and lift it up, the measurements are the same, but it's just going to be looking at a different side. So that's not the best answer. What would be a best answer? Just now, Skylar suggested. What do you suggest? 6 times 2 times 2. Will the cuboid look different? Yes. Yes, you can pick it up. You're welcome. Now you realize that one look at one layer is already very different. it will definitely not be the same one as you are looking at it. Right? Compared to the one being drawn. It's going to look like it's vastly different. Now, I guess most of us by now should be able to answer the bottom questions here. This one goes back to us being able to use the same magic principle. That if we want to find more of the measurements, we take the volume, divide by the two other measurements, multiplied together. So length will be equals to the height times the breadth. Volume divided by height times the breadth. And then the breadth will be equals to the volume divided by the length times the height. Okay, moving on, page 30. Here are some examples. You can take a look at it now. Very helpfully, some of the questions are using calculator. So you need a calculator to solve these questions. I'll talk about base area again, but I think that most of us are like, after putting your hands to the cubes for quite some time, you are feeling some exhaustion. So everybody, please return your cubes now. It will be helpful if one person can bring the container around to pick it up. Please make sure you do not have any cubes being dropped around. Yes, correct. I think we have spent enough time playing with the cubes. I'm going to move us on. I have just given out the first side of the worksheet for volumes. I just give you the first set. The homework is on page 29, 30, and 31. If you are